So the title of my talk is Photoshop to Web Adventures in Pixel Perfect Text. And just to introduce myself, I'm Shalana and I live in St. Paul, Minnesota and love it here. I'm a front-end developer at White House Custom Color. You can find us online on Twitter and Instagram, and you can follow us there, or WHCC.com. I love broomball and I play it a lot. If you get a chance to play, you should. We run on ice with really tacky shoes, and the Twin Cities is definitely a hub for the sport. And if you get a chance to play, you should definitely do it. It's great. My husband and I published a children's book not too long ago, and I bring this up because I did layout. So I put the images and text together and got it ready for the printer. And I bring this up because you kind of need to have an understanding of how print text works in order to translate that to the web. And that's what we'll be doing today as well, is translating print text to web text. I also hate word clouds, but I thought it worked here. So let's dive into more pixel perfect text stuff. So what is pixel perfect? I'm sure you've heard this before. It means you get the widths and heights and the border radius is all correct, and padding and margin and font size to what the designer gave you in their Figma file or Photoshop file or Sketch file. And some people don't really realize that it's still important to get those numbers correct, even if you're not using pixels and you're not trying to be completely pixel perfect. It's really good, I think, to make sure that you kind of are in the spirit of what the designer gave you at the very least. Like those ratios are very, very similar, because nowadays we have responsive web design, so that pixel perfect precision is not always the right thing to do, because you might not even be using pixels. You might be using percentages or rems or ems or viewport widths and heights. So I still think noticing how much space graphic designer is putting between elements is really, really important. But pixel perfect precision isn't so much important anymore. And for text, it's so not worth it that no one really realizes, or very few people are realizing, that they're not matching it, even if they try. They don't know how off that text is from, say, Photoshop or Illustrator. And then you might want to ask, well, then why are you even giving this talk? Why does it matter to be pixel perfect or close to pixel perfect in text? And our case is we are trying to match these cards. I'm creating a card editor, and I work at White House Custom Color, and it's a professional photo printing company. And I was creating a card editor tool to help photographers create and sell these cards. But we also have other products like canvas prints and frames and albums, where you'd also want to hope the thing that you see on your screen is the thing that you get in your hands. So for fidelity's sake, we want to make sure that things are lined up correctly. And our specific workflow is a designer creates a card in Photoshop, and we have this, Adobe created this great generator that you can get these assets and layer data. You can export it, which is awesome. I get it, and I can knit it back together. But you need to understand how text works in Photoshop, which is a very print-centric program. So I need to show that stuff on the web correctly, put all those assets in the right spot, and same thing with the text. There's one more translation you want to get correct. It's from web to print, and I'm not going to go into that today, but that's another thing to focus on. So some background before we get into solving these problems and answering a question that a lot of us have is, why do fonts of the same size have different heights? Why are some smaller and some bigger, and they're all, 30 pixels tall? And why does that happen? And to get there, we'll also need to talk about physical type. So way back in the day, the largest block was the character M, and that would be a square. The height and width would match. And that, of course, wasn't always, but traditionally it was. And M height became synonymous with the font size, and that's carried over to today. So the M height means, what is this font size? So in the digital world, I'm going to create, this is going to be our M height, this between these two cyan lines. And how we divide up that M height matters, and they call that UPM, so units per M. You can also still call it M height and M size. And some typical divisions are 1000, 1024, and 2048. So you can look at a font, you can open it up in an editing software and be like, well, what is this font's UPM? And this particular font's UPM is 1000 UPM. And then you can also be like, well, how tall is this A character? And it's 677 units tall. And when you are sizing, we're sizing a font, you're actually saying, I'm going to make that M height a certain size. You're not saying I'm going to make that A character a certain size. You're making that whole M height the size. So like if I set this font size to be 10 pixels, how tall would A be? So it would be like 6.77 pixels tall, or around 7 pixels tall. And this is why different fonts appear to have different sizes, is because they take up different percentages of their M height. I could make an A character that's very, very small within this M height, or really, really, really tall. It could almost take up the whole M height if I wanted it to. So that's where you get, I'm setting this font, even though they're all 10 pixels, some of them will be taller and some of them will be shorter. Some other terms you should know about, and some of these are simplified. If you look into like what's actually attached to a font, some of these have different like prefixes attached to them, but baseline is pretty much across the board. It's at the 0 marker of your metrics is the baseline, and that's where all of your text feels like it sits on this imaginary line. Then you have an ascender, and that's another word that you're going to hear associated with like characters. Like D is an ascender character because it goes above the X height, and but this line, this ascender value, goes to the top of our M height. So that 750 is our ascender value. And a descender, also you can have descender characters, like G is a descender character because it goes below that baseline. But here it means, well, what's the distance to the bottom, or to the bottom of my M height? And it's always a negative number, and this time it's 250, but if I were to add up these two distances, I will get 1000 UPM. And there's also another, I think that this is just for fun, line gap is kind of like, what is my default spacing? What should it be for this font if no spacing is like set? So people will say that your line height, if you don't set it, is 1.2 in the web, and that's false. It's actually determined by whatever font is the default for that web page, and what is its line gap determines your line height. In this case, it would still be 1.2 because 200 plus 1000, you're going to get 1.2 out of that. But if this line height was, or this line gap was 500, then it would be 1.5. So it's actually determined by the font, which is kind of fun. So challenge number 1 that I had to match is leading in the web. So what is that? So leading in Photoshop or print terms is space between lines of text from baseline to baseline. Now, that wasn't always what leading meant, because leading technically was like you'd put bars of lead between lines of text, but it morphed into meaning baseline to baseline. But that's where that term even comes from, is like it was physical lead put between these lines. So here you can see, each square will represent 5 pixels, and they're all sitting on baseline to baseline is 25 pixels. Line height is a terrible thing. I hate line height. It's the worst, and you'll see why later. But line height specifies the minimum height of line boxes within an element, which means nothing to almost everyone. But if you were to generalize what line height does, is it sits in the middle of those values. So like it kind of vertically aligns itself. But that is just a generalization. That's not really quite what line height is, but it's good enough for talking about it initially. So you'd be like, oh, this doesn't look that hard at first glance to match. All we need to do is move the line height, just, put a top margin on it and call it a day. That gets really complicated when you start varying that leading or line height. Now that matching up isn't going to be so one-to-one. So if I were to push that all of it down like looks like a square and a half for that first line, and you look at the last line, Ocean of Dreams on the right-hand side, that's now 3 1/4 squares off. So that's a big difference. You can't just push down that line. You have to look at each line, and it gets even more complicated than this. So this is just kind of like scratching the surface of how these two things get a little bit complicated. So we're gonna render what line height actually does if we were doing this in the web. We're gonna talk about how this actually works. So line height, what is it? It specifies the minimum height of line boxes within the element, which means nothing to almost everyone. So, but the big thing you should take away is line height is just a minimum. The line that you actually have may be bigger than your specified line height, and you'll see how that works in a little bit. So line box, we're going to make that cyan, so it's going to be the min and max of inline boxes, whatever those are. And our inline boxes are the line height of an inline element. So an inline element, you may be familiar with this if you have some text in a span, that would be an inline element. There's also something called anonymous inline elements, and we'll talk about those really soon. Let's look at what we have here in our HTML. We've got a div, and it's got a line height of 80, font size of 80, and a font family of Arial, and then some text inside of it. So the line height and the font size being equal is on purpose. And now it's on purpose because I wanted to make sure that, so you know that font size kind of sits in the middle of the line height. I wanted it to take up 100% of my line height. So that's definitely on purpose, and you'll see why in a little bit. So first thing they do not tell you about, and you have no access to this, is every single line of text in a block starts with a strut. And the strut is a zero width character with the block's font metrics. And that dashed line is to represent the line height of that element. So this character, of course I'm giving it a width and it doesn't have a width, but I want you to see something. Its height is going to be 80 pixels tall because that's the line height of it. And that white line is where the baseline would be if there was a character there. So that's just kind of what that's signifying. So that's the inline box of this is 80 pixels tall. And it takes the font metrics of the block, which is Arial. Good thing that everything else is Arial too, so it's going to make an anonymous inline element, and that happens with wrapping. So 1, 2, and 3 kind of get split up, so that creates one anonymous inline element, and its inline box is 80 pixels, just like the strut. There's no difference in these font metrics and sizes. So what is my line box? So the line box is the min and max of these inline boxes, and they all line up. So the top of this line box is there, and that's the bottom of that line box. No real surprises here except for that strut. So this line box, its height is the same thing as the line height. It's 80 pixels tall. Second line is going to be kind of more of the same. We're going to start with that strut again, and then we're going to have 4, 5, 6, which is an anonymous inline element with 80 pixel height for our inline box. And its line box also is 80 pixels, just the same as the first line. So right now, our line height is the same thing as our line box. That doesn't always stay the same. So here we go. We've got the same div, basically, and then I've created a span, so that's going to be an inline element with 1, 2, and 3, and it has a different font family. So let's start off. We start off with our strut, which has, Arial. It has those block font metrics, and it's 80 pixels tall because that's our line height. And then we have 1, 2, and 3, which has a different font, and its inline box is also 80 pixels tall because that line height that span will also take that 80 pixel line height. But the weird thing here is those baselines line up, which is a good thing. You want baselines to line up. You don't want to read text and it to go up and down and go all over the place. But since those baselines are at different places within my M height, our line box is actually greater than 80 pixels. So you can see that because they're like a skew. And now you've got the max of those inline boxes and the min, and now it's greater. But our second line, 4, 5, and 6, that anonymous inline element has the same line height and the same font metrics as the strut. So it's going to have a line box of 80 pixels, which is crazy. That's terrible. Like, that's completely unpredictable. And I don't know why they designed it like this. It's terrible. So we're going to fix this. We're going to make this work. We're going to make this match leading. So some of my requirements to make it match would be like, okay, we need to have predictable line box heights. It can't be wonky and all over the place. And that's kind of actually very close to number 2. It should be font independent. I shouldn't need to know these font metrics. And we want it to be equivalent to leading, which means we want that baseline to drop down to the bottom of that line box. So we're going to do this with 3 spans instead. And all those 3 spans have different fonts. Let's start off with our strut. That strut has the font metrics of Arial, and it has a line height of 80 pixels. That inline box is 80 pixels tall. And now we have our spans, and they're kind of going to do what you think they're going to do. They're going to go up and down based on their font metrics having baselines at different positions. And so our line box is once again going to be greater than our line height. Once again, line height is just a minimum. So this line box height is greater than 80 pixels. So the first thing I thought is, well, why don't we do something to these spans? Why can't we make sure that their inline boxes do not affect my total line box? So if I set that line height to 0, those inline boxes should collapse. And that's what they do. So we're going to start off with our strut because we have no say about that, and that just comes with every single line, and it has, everything that the block element metrics have. And then here's our 3 spans, and you can see the dashed line is basically where that line box, it gets collapsed, but it's centered on the height of the M. So it's in the middle of our M height for each one of those. And then our baselines still line up, which is great. And the nice thing here is at the very minimum, our line height is still 80 pixels. Okay, that's good. That's predictable at the very least. But we still have a problem with this strut having extra space below its baseline. And the strut is basically determining where the baseline of all of these are getting matched up because it's the tallest inline box. So what can I do about that? So what I decided to do is create a font, and it's just a utility font for my block elements and not for inline elements within that block. So I decided, well, let's make the UPM the same. It's got 1,000 UPM, and it's going to just have 1 character in it. This is really just we're just doing this for the metrics. And I'm going to make sure that the baseline and the descender are both at 0. And so that means we do not have anything below our baseline. And you're going to see how that works. So if I changed my font family to be some baseline font. And I've created a utility font that you can use and do this with. And you can start off, and now our strut has its baseline at the bottom. And then our line box ends up being 80 pixels, and our baseline ends up being at the bottom of our line box, and this all works, and it's amazing. So a couple of notes to this. I made that line height and that font size 80 pixels on purpose. They need to be the same in order to create your leading. So basically, the line height and the font size for your block need to be the same, and you need to use a baseline font. Those spans, however, inside your block element can be whatever font family you want, and here I've made them font size 80 just for having the math work out and show it working with just 1 font size. But those spans could have any font size as long as it's not twice the leading size. So that impact font family could be font size, I don't know, 20 pixels. That would be fine. Or font size 60 pixels. and that this would still work. So think of that div, everything that goes into the div element as being leading related. And think about your inline elements inside as being actually the font size. So here is the baseline repo. I basically have baseline M as the utility font you can use. And here's a CodePen. This one is like just kind of having fun with it. Vertical rhythm is a big thing to graphic designers. They set up a grid and then they want all the baselines to sit on this grid. It's very pleasing looking. I don't technically need vertical rhythm for what I'm doing. I actually just need to match random lettings. They might not work with a given grid. But you'll find a lot of people kind of have an obsession with the grid even when it comes to text. And I have a CodePen of this as well, and just kind of showing off. These are all web-safe fonts except for, the block font is that utility font. So I start off with having like a grid kind of defined to kind of show this off. I load that font, that utility font, showing some grid lines, no big deal. I'm setting the block elements up. You could do this in other ways. You could just set this up on the body if you wanted to instead to make your font family baseline M. And I did this little trick where I said, let's just say the line height is 1, which means match whatever the font size is, so that those two will be our leading. And then I said anything inside our block elements is going to have a line height of 0, and you could also write this in other ways. So you can see here's like a paragraph with a span. That's the hardest part about this method is you don't need to have font metrics, but you do need to have like an encapsulating inline element of some sort to make this work. So you could have lots of them if you wanted to, or you could just have one. But then here's setting up leading. So remember the block stuff is just about leading. So the font size is really my leading, and I'm doing that as a multiple of the grid and multiple of the grid for this one too. I also set up the margins to be multiples of the grid. You need to make sure like the space below these as well needs to be multiples in order to make it sit on a grid. But you don't have to make these things sit on a grid. And then the inline styles, you can kind of do whatever you want. So like the H1, basically this right here is, I've made the font size a multiple of the grid, but it doesn't have to be. I could make it like, let's make it 0.2 of that. And now it's a little bit bigger and it still works. Everything is still on the grid. So you can play around with the spans, and those are basically your font sizes. And this one I'm showing off, like this first one is like right here. This paragraph has 3 different font sizes or 4 different font sizes, and it's still working with this baseline method. And you don't need to know any font metrics, which is super fun. Okay, so that was a big challenge. Now let's talk about first line placement. Photoshop. We're going to pretend this is Photoshop, and this is the title of that book. But I'm like, well, how does Photoshop place that first line? It obviously isn't, setting it off with the leading. We got the leading to work, but what's going on with that first line? And through trial and error, I found out it was the height of the character D. They don't have this written anywhere. I just played around, and then I was like, oh, the character D, the height of it always seems to hit the top of that text box, and that's so weird. Like, why did they do that? And they just must have picked a letter and gone with it. So here's a D hitting the top. Okay, so now we're in the web, and I've already gotten my leading to work correctly, but that first line is off. And we're going to actually need to use a little JavaScript for this, and we're going to need to know a little font metrics for this. But at the very least, we only need to loop through that first line. And then we're going to move up that first line, and all the subsequent lines will be fine then. So I have a JSON file, created a little Python script that has the ratio of the D height to the UPM for each of the fonts. And then to calculate the margin, I get the max character like D value for the first line and subtract the line height. And so in this case, it'd be 39 minus 60, and I get negative 21. And that will be my margin for that first line. And here is the editor again, and I kind of want to show this to you live. So here is the card editor. And then I'm just going to put a lot of D's on this. And this was a really fun project to work on. Super, super fun to make. It's a React application. But I'm just making these all D's, and they don't hit the very top because I added a little padding. So where they're hitting right now should not really move. So like if I make some of them smaller, you're going to still see the larger one is going to hit there. And if I make this a little bit bigger, let's try, oops, I hit the wrong side. A little bit bigger, it's still going to kind of sit in the same spot. If I decide to change the font, you're still going to have the largest one is going to hit. So let's try another one. Let's make this like a really, really small font maybe. Let's see. This one looks kind of small. So then these are taller, so they end up hitting in that same spot. Really fun to be able to match that as closely as possible and to have confidence that you can do that. So some links. Adobe Generator is what helps export all those layers. Font Tools is a Python library that helped me get the value of the UPM and that de-ascender value. Draft.js didn't talk about that, but Draft.js helps you manage content editable state, and it's by Facebook, and it works with React, and it's really quite fun to play around with. And the nice thing about it is it also normalizes content editable across different browsers. They're all a little different. It's great. Some font metric and editing apps. I don't have glyphs written down here, but if you want to go pro, glyphs is like the professional font creating tool. Type Tool 3 has a demo version that is free to use that you can look at font metrics on. Font Forge, you can create fonts with it, and it's free. Font Squirrel Generator, you should definitely take a peek at that. You can alter fonts, vertical metrics, and other things about fonts online, and it's a really great, cool tool that kind of helps get your feet wet with manipulating fonts. And some web text baselining methods. You have my method, which I really like because you don't need to have any font metrics to make letting work. You just need a utility font and some CSS. But these other ones, Sassline is cool, and there's other ones out there that you can take a peek at. Articles, if you've got some time and you want to do a deep dive, the deep dive article is specifically very, very good, and I highly recommend reading through it, and really helped me understand why my method even worked by reading through this. And this one weird trick by, I think it's Alan Stearns, helped me come up with this method and fully make it work for a paragraph of text. I don't have any links here, but it's about they want to do something called like grid snapping, and that's a thing that they're requesting for CSS for text to like snap to a grid, so that would really give you your vertical rhythm. I'm not a huge fan of it, mostly because I need to match random values for letting. I don't need to snap to a grid, but I'm sure some people would really like the snapping to a grid. And then they're talking right now about something that will basically take off the stuff below the baseline and trim. I believe they're calling it trim, like trim off below the baseline and trim above an ascender value in CSS. And that'll be interesting to see where that lands and if that makes creating letting in the web any easier. Personally, I would love like a straight up letting value that I could say, I could define a letting and that would override my line height. But we'll see what happens over time. And it's interesting to see them like starting to think more about text and standards related to text and we'll see how much closer, if this can get more in line with what we can do in print. So thank you for listening to this talk. And if you have any questions, you can reach out to me on Twitter, and I'm also on GitHub if you want to follow me there. You can take a peek at what White House is up to at WHCC.com. And yeah, thank you very, very much. I hope you learned something. If you find a better method for creating leading in the web or other font metric stuff that you're fascinated and are interested in, let me know. Thank you.